Hello everyone, this is Shiva from Group 1. Today our topic is about Spaceship Titanic, and these are the names of the group members. These are the contents which we have covered. And coming to the introduction, in the year 2912, the Spaceship Titanic faced a space-time anomaly in the Alpha-Centauric system, causing nearly half of its 13,000 passengers to vanish into an alternative dimension. Using recovered data from the ship systems, we aim to predict which of the remaining 4,300 passengers were affected by this anomaly. Our model trained in information from 8,700 passengers incorporates unique to identities, home planets, psycho sleep status, cabin details, destinations, ages, VIP statuses, and etc. The predictive system is crucial for guiding rescue missions and enhancing system in future interstellar traveler endeavors. And coming to the data field description, the Spaceship Titanic dataset includes passenger records, splits into training and test data. Each passenger has a unique passenger ID with a unique code GGG underscore PP. The key details are home planet, destination age, VIP status, and expenditures. The target variables are transported indicates the passenger was shifted to another dimension. Predictions for the test set should follow sample submissions.scv listing passengers and predicted transported status. And this is the train data which we have used, which is having the information about all the passengers. And these are the scatter plot analysis. And this is the distribution of age and onboard amenities usage among the passengers. And next slide will be continued.
Coming to the data cleaning, the data sets has no null values in any complex, which has given in the picture right behind. So there are different topics like the homoplans, CRISPR slides, cabins, destruction age, VIP room service, and all the stuff which we have right there. Next slide goes to the data variables. The data sets include various details about the passenger on a space token, such as passenger, home planet, pre-slave status, obtained details, and age, VIP status, and etc. And each row represents a different passengers with the transported column indicators which they were successfully transported. The subsets of proposed sleep VIPs and transported. Next. The details here are distribution of age using KDE plot. The KDE plot for the distribution of age among the passengers of the spaceship Titanic reverse underlying of the sky blue. The second one goes with the count, the number of VIPs and non-VIP passengers. Like the percentages will be given like this, like 2.5 from our data, and the rest 97.5 for the other data. On the next slide, pair plot for the numerical features and 4-point with the plot of categories features. We have given the structure of this plot, everything right here with the regions from -1 to 1, and white with the -1, significance a perfect negative categories, and age deficiency room services, the 0.13 between VIP status and space uses. The data aggregation, certainly we experimented determination across different homoplans. We can analyze the mean ages properly for each. The mean age represents the average of a population calculated by the adding up by age and dividing by the total number of individuals. So from our data, we got the men's age of 24 years, and including home page one, with the man age of 33.0 years, 0 years. So these are details about the age of the people of men's. Distribution and density of room services and food court access human plants. Data right here is the distribution planets, and we got the Homo plants range from 0 to 0.0025, and the food count, the range of the 0.00020 with the additional value of 0.0015. So the density of the service range from the 0 to 0.0010 for the plant strategies.
The insights from the room service and food court distribution across the home planets. Here we see the distribution services of room service and food court across different home planets offers variable insights into the utilization and demand patterns of services. Here we see the understanding the and the preferences needs the different populations across home planets. The next slide is distribution of distribution of age by home planet. The provided data presents the distribution of home planets. This information can be valuable for understanding the age diversity and demographic among the populations residing or using services on these home planets, aiding in targeted marketing or service customization strategies. Here we can see the graph over here. And the next slide is descriptive statistics and room service utilization by home planet. The home planet column shows us the passengers from three different home planets predominantly and home planet 0. Here further analysis by home planet indicates the very room service utilization ranging between 200 to 500, hinting at divergent customer preferences and necessitating the tolerated resources allocation strategies. Here we see the graph and the result over here. And the next slide is, it will be continued by my friend.
Distribution of the home services by the home planet using the point plot. The point plot is using room services users across the various home planets would detect how the service demand changes with different locations. And the data seems to show the food court usage by home planet categorized by age and VIP status. With the age groups ranking from 0 to 75 and the VIP status being binary into the customer behavior and the performance across the demographics. Next slide. Age distribution transported and the VIP status and room service usage insights and from visualizations. The data appears to represent the age distribution conquering transporter status and the VIP status. The graph, the plot displays the relationship between the age and the room services usage, showcasing how room services define the changes across the different age groups, like X-rays presents age ranking from 0 to 80. Next slide. Insights from passenger distribution and the room services usage across the home planets. First is a percentage distributing of the passenger across the home planet, and the second distributing of the home services across the home planet. Over to you, Vijay.
Yeah, here I'm going to explain how the filter data for passengers who use the room services. Here we can see the two graphs that represents on x-axis on the age from 0 to 80 and on y-axis how they were spent on the food courts. Here this plot visualizes the correlation between the age and food court. And the second graph, here we can see the correlation 0 and -1 and +1. Among the age, we can see the difference here. The age of range from 20 to 50 users utilizes the more food courts Come to next slide. Here you can see the relation distribution plot. Here on x-axis, it again on age, and on y-axis, it determines food court usages. Here we can see the regression line that varies from age. Here again, here the food courts are majorly used of the age 20 to 60. Here we can see the troughs and peaks in this regression line. Coming to the next slide. This is the joint distribution of age and food court use with KDE. KDE refers to kernel density estimation, which visualizes technique that combines scatter plots of age versus food. Here we can find interpretation by examining the joint distribution with KDE. You can infer several insights. Coming to next slide. Here the linear regression is similar like a regression line. We can see the age on x-axis and food court uses on y-axis. While the regression line helps to identify the overall trend or correlation is between age and food court. Age, while the negative slope implies the opposite, and the plot aids in understanding how age influences food court visits and can be useful for predicting likely usage based on person's age. Next slide. Next slide will explain by my friend.
Coming to the confusion matrix, this evaluates a model's performance by categorizing predictions into the true positive, true negative, and false negative. These categories help understand the model's accuracy in distinguishing between the two classes, either positive or negative. Also, the metrics like accuracy, precision, recall, and specifically provide further insights for this home planet. Accuracy measures the overall correctness of the prediction, whereas the precision and recall focus on identifying positive instances correctly and avoiding false positives or negatives. To conclude, Spaceship Titanic data and dataset analysis explores the relationship between the factors such as age, home planet, Kairos sleep status, cabin type, and also the amenity usage, which affects the likelihood of passenger being transported to another dimension. This analysis reveals the patterns in amenity usage across different home planets and age-related trends in room service and also the food court use. So the key insights include correlation between Cairo sleep status and the VR deck usage and unique behavior patterns among VIP passengers. These insights highlight the importance of considering various factors in space travel, also the safety and passenger experience. By using these insights, predictive models can determine which passengers were affected by space-time anomalies, aiding rescue efforts and future interstellar travel safety. And this concludes our final project. Thank you.